So permanent dipole is for polar molecules. Permanent dipole is for polar molecules. So you people know what a polar molecule is, right?
Yes, sir.
Ionic compound.
Huh?
Ionic compound na?
Ionic compound, nah. Polar molecules,
Asymmetrical shape.
which has asymmetrical shape and which has an overall charge, So for example, CH3,
Water.
C11O, CH3. This molecule is polar. Why is it polar? Because it has a very electronegative atom. So আমরা জানি যে what are the electronegative, who's the most electronegative atom?
Nitrogen.
Fluorine. Then
Oxygen,
then
nitrogen, then
Phon.
fluorine.
Phon, okay? Fluorine, oxygen, and nitrogen. So whenever you see that in an atom you have fluorine, you have an oxygen, you have a nitrogen, you would understand that the molecule is polar and it will give rise to permanent dipole forces. Clear? So permanent word, what does the permanent word mean? That it's always there. It's always there, okay? Permanent dipole forces means it's always there, and that is present between polar molecules. So what happens is a bond's natural polarity caused by the different electronegativities of the bonded atoms can be increased by nearby. This is basically how force can be induced. So this is actually not part of it. Actually, it is going to be below this. This is going to be how this is an experiment of how van der Waals forces arises. So permanent dipole forces are present when there are very electronegative atoms, and it is present only between polar molecules. Okay, it's present between polar molecules. So permanent dipole is for polar molecules. Permanent dipole is for polar molecules. So you people know what a polar molecule is, right?
Yes, sir.
Ionic compound.
Huh?
Ionic compound na?
Ionic compound, nah. Polar molecules,
Asymmetrical shape.
which has asymmetrical shape and which has an overall charge, So for example, CH3,
Water.
C11O, CH3. This molecule is polar. Why is it polar? Because it has a very electronegative atom. So আমরা জানি যে what are the electronegative, who's the most electronegative atom?
Nitrogen.
Fluorine. Then
Oxygen,
then
nitrogen, then
Phon.
fluorine.
Phon, okay? Fluorine, oxygen, and nitrogen. So whenever you see that in an atom you have fluorine, you have an oxygen, you have a nitrogen, you would understand that the molecule is polar and it will give rise to permanent dipole forces. Clear? So permanent word, what does the permanent word mean? That it's always there. It's always there, okay? Permanent dipole forces means it's always there, and that is present between polar molecules. So what happens is a bond's natural polarity caused by the different electronegativities of the bonded atoms can be increased by nearby. This is basically how force can be induced. So this is actually not part of it. Actually, it is gonna be below this. This is gonna be how. This is an experiment of how van der Waals forces arises. So permanent dipole forces are present when there are very electronegative atoms, and it is present only between polar molecules. Okay, it's present between polar molecules. Third, let's come to hydrogen bonding, the strongest intermolecular force. So what happens here? So hydrogen bonding এর দুইটা criteria আছে. Hydrogen bonding এর দুইটা criteria আছে. First of all, we know that intermolecular forces are between molecules. There, it has to be between the molecules. So ekhaneo it is between the molecule. So let's take two molecules, water, HOH. So in water, hydrogen has what type of charge? Positive or negative?
Double positive.
Positive.
Positive. Why? Because oxygen is more electronegative atom, so it has more negative charge. So this is partially negative, this is partially positive. Let's take another molecule of water. This is partially positive, this is partially negative. So water is a polar molecule or a non-polar molecule?
Polar.
Polar molecule. Okay. So tamane hydrogen water molecules has three types of forces acting. Number one, van der Waals forces. So during the video did you follow that van der Waals forces are present between all type of molecules? Did you follow that line?
Yes, sir, you said that.
So van der Waals forces are always present between the molecules, always present between all type of molecules. Number two, since water has a very electronegative atom, what type of forces does it have? Permanent
Dipole.
Permanent dipole.
Hydrogen bonding.
Third, so van der Waals forces are present between non-polar and polar. Permanent dipole is present only between polar, but hydrogen bonding is present only under certain circumstances. What are the circumstances? So Amra, let's take this as molecule number 1. This is our molecule number 1. This is our molecule number 2. So molecule number 1, for hydrogen bonding to occur between two molecules, we need one molecule having a hydrogen atom covalently bonded to either fluorine or oxygen or nitrogen. So in this molecule, hydrogen is bonded to fluorine, oxygen or nitrogen. Which one? It's bonded to oxygen.
Oxygen.
So in one molecule, mind it, this is one of the molecule. This is molecule number 1. This is molecule number 2. So molecule number 1 has a hydrogen atom which is covalently bonded to either fluorine or oxygen or nitrogen. And molecule number 2, a hydrogen, molecule number 2, a fluorine or an oxygen or a nitrogen atom with an available lone pair of electrons. So this oxygen has how many lone pairs of electrons?
2.
Molecule number 2, which has an oxygen, has how many lone pairs?
2.
2. So they'll donate this lone pair to this hydrogen. So I'll repeat. Hydrogen bonding has two things. One of the molecule, hydrogen has to be bonded to either fluorine or oxygen or nitrogen. And in molecule number 2, there has to be a fluorine or an oxygen or a nitrogen which can donate a pair of electrons. So cano, why does this hydrogen bonding occur only when there are very electronegative atoms? Now listen. What is electronegativity? What is electronegativity?
The ability to pull a pair of electrons
Sorry?
towards itself.
The ability of
Ability to pull a pair of electrons towards itself.
It's the ability of an atom to attract the shared pair of electron towards itself. So we know that oxygen is very electronegative, right?
Yes.
So what it does is এই যে এখানে যে shared pair of electron যেটা আছে, it pulls it all towards itself.
Oxygen.
So what happens to hydrogen? Hydrogen এর তখন electron deficiency হয়ে যায়. Hydrogen is left with no more electrons. But in order for hydrogen to become stable, or in order for hydrogen to have a full outer shell, what does it need?
2 electrons.
It needs 2 electrons. So that's when the lone pair of electrons comes into play, and they donate these pairs of electrons to the hydrogen atom. So water has how many oxygens?
1 oxygen.
And 1 oxygen has how many electron pairs?
3,
6.
4,
3.
4.
3.
No. 2.
4.
Lone pair.
A lone pair.
Lone pair 2.
Lone pair 2. So each water molecule can form how many hydrogen bonds?
2.
2. Acha. Ammonia is another example. So one of the molecule has a hydrogen bonded to either fluorine, oxygen or nitrogen. Which one does he have here?
Nitrogen.
Nitrogen. Another molecule has to have a fluorine or oxygen or nitrogen present with a lone pair of electron. Does nitrogen have a lone pair of electron?
Yes.
How many
Yes,
pairs of
that's
electron does nitrogen have?
1.
So how
One
many
lone
hydrogen bond can it form?
1 lone. 1.
Can form 1 bonds. 1. That is the reason ammonia is gas at room temperature, water is liquid at room temperature. So hydrogen bonding er ei duita criteria is very, very, very important. It's very, very, very important. Okay. So tumra jeta koro, you write down what is hydrogen bonding. Write down what is hydrogen bonding. Write down what is hydrogen bonding. Sorry.
Last points gulo.
And arekta jinish I want to add is molecules who can form this hydrogen, covalent molecules who can form hydrogen bonds are only soluble in water. Okay? Sure. Covalent molecules who can form hydrogen bonds with the water molecule are the ones who are soluble in water. Clear? এটা লেখো, এই যে এটা লেখো, আমি যে ডায়াগ্রামটা এঁকে দিছি, আমি যে এই যে ডেসক্রিপশনটা এটা লেখো everybody. So water has 3 things. Van der Waals forces, water has 3 forces acting, or 3 intermolecular forces. Van der Waals forces, permanent dipole and hydrogen bonding.
So permanent dipole টা কিসের সাথে হয়?
Oxygen. Hydrogen or oxygen এর কি difference in electronegativity is very high, right?
Oh হ্যাঁ হ্যাঁ।
So it's a polar molecule, and polar molecules always give rise to permanent dipole-dipole. So last class we studied about intermolecular forces. What are the three types of intermolecular forces?
Hydrogen bonding, van der Waals forces, and permanent dipole-dipole forces.
ठीक है sir. So we study, so for non-polar molecules, what type of intermolecular forces do we have?
Van der Waals force.
Van der Waals forces. Okay. For non-polar molecules, we have Van der Waals forces. ठीक है. So non-polar molecules. Asho. Non-polar molecules, we have Van der Waals forces. For polar molecules, what do we have?
Permanent dipole.
Permanent dipole.
Permanent dipole.
And van der Waals.
Permanent. No, sorry. For polar molecules, Van der Waals forces is always present, irrespective of what type of forces. And especially we have what? Permanent dipole-dipole. Permanent dipole-dipole. And in special cases, what do we have? Hydrogen bonding. In special cases, we have hydrogen bonding.
Hi, sir.
Hi, Nikita. Why are you so excited?
Not just excited. I don't know why.
Oh, because you woke up early in the morning, and then you had to do classes, and now you're again doing classes. So you're just pissed off.
Hey.
Acha. So polar molecules, we have Van der Waals forces, which is always present. In all types of covalent molecules. And then especially we have what? Permanent dipole-dipole. And under certain circumstances, they can also have hydrogen bonding. Golam Abrar, তুমি কি আছো? Golam Abrar. গোলাম নাই।
আছি স্যার।
হ্যাঁ গোলাম শোনো, তুমি আমাকে বলো যে what are the criteria of hydrogen bonding? Hydrogen bonding form হতে কি কি লাগে? What are the criteria?
Oh, হ্যাঁ স্যার। One molecule having a hydrogen atom covalently bonded to F or O or N.
Very good. One of the molecule has to have a hydrogen
Atom
bonded to a
fluorine.
oxygen, fluorine, oxygen or nitrogen. Acha gelo.
And the other molecule I have to have a lone pair থাকতে হবে স্যার, fluorine, oxygen আর nitrogen atom.
আচ্ছা হ্যাঁ। So আমরা, if this is molecule number 1, here hydrogen is bonded to a, in this molecule it's bonded to oxygen, but it could either be bonded to a fluorine or a oxygen or a nitrogen. Okay. And second molecule ki?
Second molecule has to have a lone pair.
Second molecule has to have a fluorine or a oxygen or a nitrogen with lone pair of electrons, which have a look here. Have a look here. Sorry. we can see hydrogen is bonded to this lone pair. So what is this?
Hydrogen bonding.
Hydrogen bonding. So everyone, can you please repeat? So in one molecule, a hydrogen has to be bonded to either a fluorine, or oxygen, or a nitrogen. A second molecule has to have oxygen, fluorine, or oxygen, or a nitrogen with a lone pair which it can donate, right?
Yes.
So only, why is it only happening when these three atoms are present?
They are the most
The most electronegative atoms.
Electronegative elements.
So they're very electronegative. They're already taking away electrons of this hydrogen towards itself. So now hydrogen is deficient in electrons. To fulfill this, they're taking electrons from the lone pair of another atom, which could be either fluorine or oxygen or nitrogen. Any শুনো, হাইড্রোজেন বন্ডিং এ কারো কোনো প্রবলেম আছে?
না স্যার।
The hydrogen bonding আর covalent bond দুটা similar না? ডিফারেন্সটা বুঝিনি দুটো।
Hydrogen bonding does not completely, dative covalent bond happens within an atom, within a molecule. This is an ammonia molecule. Ammonia molecule has a lone pair of electron. This lone pair of electron is donated to hydrogen ion. So this is happening within a molecule. And this is between the molecules. These are intermolecular. This is between molecules. And this is within a molecule. Faizan, buchho me?
Yes, sir.
Sir, could you please repeat it?
Write it down. Hydrogen bonding occurs. Hydrogen bonding is between molecules. Between molecules are dative covalent. Dative covalent is within a molecule. Within a molecule.
Sir, within.
Within a molecule.
Sir?
Yes.
Sir. অ্যালুমিনিয়াম ক্লোরাইডের তো আপনার মলিকিউলের সাথে বন্ড হয়, ডেটিভ কোভ্যালেন্ট বন্ড ফর্ম করে।
কোনটা? What?
অ্যালুমিনিয়াম ক্লোরাইড। তো ওইটা মলিকিউলের সাথে হয় না?
Al2CL6.
Al2CL6 is together a molecule.
Okay.
Sir, panel
একটু স্ট্রাকচারটা একটু দেখ।
Al2CL2
এর স্ট্রাকচারটা আমি মানে বুঝিনি।
Al2CL2
নেটিভ কোভ্যালেন্ট বন্ডের
Al2CL6. Al2CL6. So this is the structure of Al2CL6. So here we have one aluminium. So a aluminium take amra dhori je this is the red aluminium which is bonded to one chlorine, two chlorine, and three chlorines. Aita aluminium has a chlorine and a chlorine and a chlorine. So this aluminium has how many electrons around aluminium? 2, 4, 6. How many does it need?
2 more.
So who's donating it? This aluminium is donating. This chlorine is donating it. Again, this aluminium has how many? 2,
6.
4,
6.
6. So who's donating it? This is donating it.
Chlorine.
Chlorine. তাহলে কি পুরাটা মিলে একটা molecule হলো?
Yes, sir.
Yes.
So this is Al2Cl6. This is dative covalent bond. So dative covalent bond occurs within a molecule, and hydrogen bonding occurs between the molecules.
molecules.
আর আরেকটা হলো যে hydrogen bonding কিন্তু তুমি there is not a complete transfer of electrons, right? এখানে কিন্তু মানে ওইখানে hydrogen bonding এ another molecule is donating electron to another one of the molecules. Here they're intertwined, they're sharing electrons. এখানে কিন্তু they're sharing electrons. Any further question?
No, sir.
Sir, এটা তো Al2Cl6 না?
Al2Cl6.
মানে এটা। আচ্ছা।
Sir, can you please repeat? Actually, আমার net চলে গেছিল।
Who has the problem?
Sir, me, Raisa.
মানে হঠাৎ করে নেটের খুবই প্রবলেম কি what do I need to repeat বলো what do I need to repeat
ওই যে স্ট্রাকচারটা এটা লাস্টে বললেন Al2C6 এটা
তুমি কি ডেটিভ কোভ্যালেন্ট বন্ডিং এ ছিলা ডেটিভ কোভ্যালেন্ট বন্ডিং এর সময় ছিলা না রামা
না স্যার
রামা
Yes.
এই রাইসাকে তুমি রাইসার সাথে বসে find out a suitable time for both of you, help her with bonding কারণ ও আসলে বন্ডিং কিছুই বুঝবে না because she missed. So রাইসা তারপর হলো ফাইজা জারিন.
Okay.
Who else? Anaf Parvez.
Yes, sir. I could use one too.
Anaf Parvez. Who else missed bonding? Chemical bonding. Who else missed chemical bonding?
Sir, our chemical bonding problem.
Comment on the chat box. Comment on the chat box. Kader extra help lagbe. Comment on the chat box. Rama is gonna help you out.
Yeah, we'll come up with a time that works for all of us.
হ্যাঁ সো তুমি যারা কমেন্ট করছে তাদেরকে তুমি you talk to them individually and give a particular time, but obviously it has to be on a weekend কারণ ওদের সকালে ক্লাস থাকে. So weekend-এ find a suitable time for you and them আর তখন তুমি বসে ওদের সাথে sort out, okay?
Yeah, sure.
হ্যাঁ আনহার মিস্ট, আহনা পারভেজ, নাবিলা রিম, সামরিন সামারা. Who else? Who else? Tanas, Shanil, do you need help?
Yes, sir. I think I could use an extra class.
Please comment on the. আচ্ছা আমাকে privately পাঠালে আমি কি how would Rahman know? Don't send me privately. তোমরা write it in the group.
Option off করা.
হ্যাঁ তাই. Oh, sorry. Everyone দিয়ে দিচ্ছে. So please, sorry again. Please একটু আবার কষ্ট করে. Okay, so let's proceed. আমি আবারও রিপিট করে দিচ্ছি এটা। So aluminium, normally aluminium chloride, due to its electronegativity difference, they are covalent bonds. They form covalent bonds. So aluminium has 6 electrons around him. This aluminium also has 6 electrons around them. So although chlorine is donating 1 here, it still has 3 pairs of electrons which are completely idle. They're lone pairs. So they're donating one of the pairs to this aluminium. This chlorine has also donated one electron to this aluminium, and it still has 3 pairs which are idle. Sorry, আমি ভুল লিখছি, sorry. This aluminium has 3 pairs of electrons which are still idle. They're gonna donate this to this aluminium. This chlorine is donating to this aluminium. This chlorine is donating to this aluminium. This is dative covalent bond. Okay.
Sir, I have a question.
আচ্ছা গাইজ, যারা যারা আমাকে প্রাইভেটলি মেসেজ করছো, write down your names again so that Rama can make the list for you and she'll sit with a special class with you people. Bolo, your question please.
Yeah, why do they give the electrons to the, why does the
We cannot hear you, Mahdi.
Why does the chlorine atom donate to the aluminum?
Okay, so why does the chlorine atom donate electrons to that aluminium?
Yes.
Is that your question?
Yes.
Because this aluminium is electron deficient and he needs electrons. So if he sees that around him he has free electrons, he just takes in those electrons so that it can have a full octet. Yes, Isfar.
Chlorine.
Isfar?
Yes.
You raise your hand.
Oh, no, it was a mistake. Sorry.
আচ্ছা স্যার, তাহলে ক্লোরিনের তো যে অক্টেটটা ওইটা থেকে দুইটা ইলেকট্রন চলে গেছে,
চলে যাচ্ছে কেন? They are sharing electrons. They are sharing. Dative covalent bond. Dative covalent.
Sorry, okay.
It's dative covalent bond. Covalent bond means it's sharing. But normally, in a regular covalent bond, out of a pair of electron, 1 electron is donated from each of the atom. But in dative covalent bonding, both the electrons are donated by one of the atoms. That's the difference.
Okay.
Okay. So next is, how does hydrogen bonding affect? Dekho, HCl, HBr, HI. They are all polar or non-polar molecules.
Polar.
Polar molecules. Acha, they're polar molecules. So if they're polar molecules, they're supposed to have van der Waals forces as well as permanent dipole, right?
Yes.
Yes, sir.
Okay. What is HF? Why is HF the highest? Wasn't it supposed to be here? Why is it here?
They have strong hydrogen
It
bonding.
has strong hydrogen bonds.
They have strong hydrogen bonding. So that is why although he's supposed to be a gas at room temperature, but actually it's a liquid due to hydrogen bonding. Everybody clear about this?
Yes, sir.
Boiling point টা কেন জানি ইনক্রিজ করে?
Boiling point?
HCl, HBr, HI তে।
তুমি বলো। HCl, HBr, HI. সবাই H is same. What is different?
The halogens.
Halogens. তাহলে halogens এ কি হচ্ছে? What is happening? Chlorine bromine আর iodine ভিতরে what is changing?
Electron.
The number of
Size of the
electrons
atom.
the number of electrons or size of the atom is increasing. So since the size of the atom or number of electrons are increasing, কি হবে?
Strength বাড়বে, intermolecular forces.
Intermolecular forces strength বাড়বে, কেন বাড়বে?
More electrons, more protons, so more attraction.
Who can answer this? Muzammil?
Van der Waals force.
হ্যাঁ, তোরাবি বলো।
Van der Waals forces.
Van der Waals forces are increasing. Van der Waals forces are increasing. So from HCl, HBr, HI, there's a gradual increase in the boiling point. Why? Because down the group, number of electrons are increasing. Number of electrons are increasing, Van der Waals forces are increasing, therefore melting and boiling point is also increasing. But abnormally, hydrogen fluoride is higher. Why? Because
Strong hydrogen bonds.
because of hydrogen bond. Because of hydrogen. Yes.
Sir, hydrogen bonding এর কি দুইটা ক্রাইটেরিয়া তো ফুলফিল করে এইচআর
করে না?
তো সেকেন্ডটা কি হবে সেকেন্ড ক্রাইটেরিয়া?
আচ্ছা আমরা দেখি। So in one molecule hydrogen has to be bonded to either fluorine, oxygen or nitrogen. এটা কি ফুলফিল করেছে?
Yes sir.
And another molecule fluorine has to have a lone pair of electron. So fluorine is donating one here. How many is it remaining? Fluorine last shell কয়টা electron? 7. Out of 7 it's donating 1. How many is remaining? 6. Then out of 6 can't it donate a pair of electrons?
Yes.
আচ্ছা যার কোশ্চেন ওকে ইয়েস বলতে বলো। ফারহান রুবাই বলো।
স্যার ডোনেট কেন করবে শেয়ার করবে না?
ওই তো শেয়ার হ্যাঁ।
তাহলে
ইয়েস ফাইজান।
Chlorine, bromine, chloride আর bromide আর iodide এর সাথে এরকম হয় না কেন? Because electronegativity কম ওদের, তাই?
হ্যাঁ, ইলেকট্রোনেগেটিভিটি কম এজন্য। So if you want to have a clearer concept, তাহলে আমরা we can go back to the electronegativity chart. Electronegativity chart. Where is electronegativity chart? Here. So hydrogen has an electronegativity of 2.1. Fluorine has an electronegativity of what? 4. So what is the difference? 1.9. Hydrogen with oxygen 2.1, our oxygen is 3.5. What is the difference? 1.4. Hydrogen with nitrogen 2.1 are 3, 0.9. So this is one of the measure. Arekta measure holo je they all have only 2 shells. So obviously it can pull the electrons. It can pull electrons very strongly. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, they all belong to which period? Period 2. So period 2 te, first of all, they're very highly electronegative, and obviously, and they also just have 2 shells. So it can pull the electrons the most strongly. Clear? Clear, everyone?
Yes, sir.
Yes.
Okay, so let's just get done with this. So hydrogen bonding e karo kono problem hoche? Hydrogen bonding?
No, sir.
No, sir.
So again, the boiling point of water was supposed to be here. Why is it here?
Because of hydrogen bonding.
Because of hydrogen
Because of
bonding.
hydrogen bonding. Because of hydrogen bonding. So what is enthalpy change of vaporization?
Energy required
energy
to
like
boil a
vapor.
boil a
Turning to a vapor.
Called in physics. Latent heat.
What is
Something like the
latent heat of vaporization?
amount of energy required per degree Celsius something to change state from liquid to gas.
It is the energy required
Yeah.
to change the temperature
Of
of
1 kg
1
of
gram of a 1 gram of a substance.
1 kg? Or
Of 1 kg. 1 gram of a substance by 1 degree. Or 1 kg
by 1 Kelvin.
by 1 Kelvin.
The specific latent heat.
Specific. So obviously hydrogen sulfide, hydrogen H2SE, and wait, আমরা একটা জিনিস একটু না এটা কাটার সময় ভুলেছি। আচ্ছা, so H2S, H2SE and H2TE. 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 So they're all gradually increasing. Why are they increasing?
Van der Waals force is increasing.
Because Van der Waals forces are increasing. Okay. But exceptionally, why does water have such a high hydrogen boiling point?
Stronger.
Shabash. Due to hydrogen bonding, water has a very high surface tension and viscosity. Surface tension key. What is surface tension?
The molecules hold on to
because of the polarity they like hold on to each other. Something like
Okay. So molecules are very tightly packed. এটার জন্য কি হয়? Plants can float on water. Ants can walk on water. তুমি জানো আমাদের লাংস কোলাপস কেন করে না? তোমরা কি জানো?
Because of this surface tension. I'm guessing.
Because of a surfactant layer. There is a surfactant layer. So 6 মাসের বাচ্চা কেন বাঁচে না? 6 মাসের বাচ্চা বা 6.5 মাসের বাচ্চা কেন বাঁচে না? Because তোমাদের তখন বাচ্চাদের surfactant layer তখনও তৈরি হয় না. It's not ready. এর জন্য বাচ্চারা বাঁচতে পায় না. But the surfactant layer is usually ready by 7 to 7.5 months. So after that, children usually survive. But এটা হলো আমাদের বাংলাদেশের perspective. আমেরিকাতে if a baby is born after 24 weeks, they can help the baby survive. That's America. So 24 weeks এর পরেই ওরা they give you artificially they inject surfactant layer so that the lungs does not collapse. So ডুবানোর তো কিছু না
মানে being born after 6 months.
When you're in your mom's womb, your lungs are collapsed. They stay in a collapsed form. So বাচ্চা যখন when they come out in the world, they start breathing and the lungs suddenly inflate. So if you don't have the surfactant layer, it will not inflate. এর জন্য বাচ্চা বের হয়ে কান্দে।
What?
বাচ্চা বের হয়ে কান্দে না কেন? Why do they check whether the baby is crying or not?
কানলে কি হবে?
ডাক্তার মারে দিলে তো ব্রিথ করবে।
হ্যাঁ,
না কাঁদলে মারে।
হ্যাঁ,
এইজন্য না কাঁদলে মারে, রাইট?
মারে না, it's to help them breathe.
Yeah, I know, but still technically
stimulus দেয়।
মাথার মধ্যে মার দিছিল।
They rub on the back. কে তোমার সাহাত তোমার মাথার মধ্যে বাড়ি দিছিল?
মাদি। আমি তো ঠিক
ও
আছে
আচ্ছা
I will
হতে পারে।
seriously kill you after the quarantine.
মাদি
And FYI, I came out 5 days after my predicted date, okay?
এর জন্য তুমি you are like overgrown.
Probably, I guess I was supposed to
Okay,
come on October
okay, enough.
হয়ে গেছে, অটিস্টিক হয়ে গেছে,
হ্যাঁ ঠিক আছে ঠিক আছে
বেশি কুমড়োজন হয়ে গেছে।
চুপ চুপ why is ice less dense than water এটা তোমাদেরকে ও লেভেলসে পড়াইছিলাম?
No.
স্যার জি স্যার।
বলো তো কেন?
আব্দুল্লাহ
হ্যাঁ বলো
সবকিছুই জানে, ওকে বলে লাভ নাই।
স্যার
আমার
এগুলা
মনে হয় আমি পড়াইছিলাম, তারপরে বলো।
স্যার যে ওয়াটার মলিকিউলস,
হ্যাঁ
ওয়াটার মলিকিউলগুলা অ্যারেঞ্জড হয়ে যায়, মানে গ্যাপ হয়ে ভিতরে মাঝখানে, এটার কারণে ডেনসিটিটা কমে যায়, মানে গ্যাপ হয়ে যায়,
So
ভলিউমটা বেশি
yes,
নেয় না।
exactly শুনো, water molecules are normally arranged like this. What is the shape of water molecule? Bent.
104 degrees না 0.5
104.5 degrees, yes, 104.5 degrees. আচ্ছা, so normally they're like this. So ধরো যে in a box, আমরা যদি এরকম একটা বক্স ধরি, imaginary, suppose here 20 molecules of water can fit. Achha. But when the water becomes ice, তখন ওর shape হয়ে যায় hexagonal like this. তখন his shape becomes hexagonal. So hexagonal যখন হয়ে যায়, hexagonals have more space in between. দেখো, this space is free, this space is free, this space is free. So what is happening? Who is more regularly arranged, water or ice?
Ice.
No, water is, sorry, more compactly arranged, sorry, regularly, compact.
That's ice.
Water is more compactly arranged, karon their molecules are more closer, but when they change their shape and become hexagonal, for the same amount of volume, 10 ice molecules can fit in. So if you have less number of molecules, তাহলে কি density বেশি থাকবে নাকি কম? So that is why ice is less dense than water, and ice can float on water. বুঝছো তোমরা?
Also why ice like expands, like
Sorry,
just while it freezes water, is that why it expands?
I mean, I'm not getting you. No, ask your question.
So why does ice expand?
Why does ice expand? Acha.
ভলিউম কমলে, সরি, ভলিউম বাড়লে ডেনসিটি কমবে, that's it.
কি hexagonal হওয়ার কারণে কি আর বড় হয়?
না. Nikita's question is, why does it become hexagonal? Is that the question?
Yes.
Why does it become hexagonal? So যখন তোমার, when your temperature is decreasing, what is happening? The molecules are coming closer to each other, right? And since it's coming closer to each other, water molecular একটা problem কি? It forms hydrogen bonds. So since it forms hydrogen bonds, the molecules arranged as hexagons. Okay, what is the temperature at which water is the most densest?
0 degrees.
No.
0.1.
No. 4 degrees. কে বলছে এটা? 4 degrees? Very good. Whoever answered this, very good. Who answered? 4?
Sarah Raida.
Okay, great. Thank you. So 4 degrees. Water is the most densest at 4 degrees. আমি কিন্তু এইগুলা তোমাদের extra knowledge দিলাম. It's not part of your syllabus. But it's always good to learn as much as possible, right? ask as much questions as possible. Current A levels is like a foundation course for your university. That's why A levels is so difficult. So A levels এ দেখো O levels আমি তোমাদেরকে A levels এর অনেক কিছু কিন্তু পড়াই দিছি কেন, so that A levels এ এসে তোমাদের প্রবলেম না হয়। এখন A levels এও আমি I want to teach you as much as possible so that when you go into university you don't need to take so much pressure. Okay, next is bonding and physical properties. So ionic compound physical properties to jano, high melting and boiling point, right?
Yes sir.
They conduct electricity in molten state but not in solid state, blah blah blah. These are the physical state at room temperature. So what is the normally what is the physical state of ionic compounds at room temperature? Solids. Why?
Strong electrostatic forces.
Strong ionic bonds. Strong ionic bonds. Acha. Metals normally room temperature. Metals at room temperature, which state does they exist in?
Solid.
Why?
Strong metallic bond.
Strong metallic bond. Okay, very good. Covalent compounds. Covalent compounds, simple covalent compounds normally exist as what?
Solid or gas.
Liquid or gas. Why?
Because of the weak
intermolecular forces.
Weak van der Waals forces.
Weak van der Waals or weak intermolecular forces. এই তো সবাই তো পেরে গেছে, very good, very good.